Geometry section 6.4, mid-segments of a triangle. If we draw a segment from the midpoint to another midpoint, we call this the mid-segment, and it has special properties. If you draw a segment from midpoint to midpoint, this segment, DE, will be half of this side that it's opposite from, AC, and they're always going to be parallel. We put this together in the triangle mid-segment theorem. A segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So we see D is the midpoint of AB, E is the midpoint of BC. So DE is the midsegment. It's parallel to AC and it's going to be half its length. Let's apply this theorem. In exercises 1 through 3, DE is a midsegment of triangle ABC. Find the value of x. So since DE is the midsegment, it's going to be half of 28. So 1/2 times 28 is 14. So we could say that DE is 14, which is x. In number 2, DE is the midsegment, which is 15, and x is going to be twice as much as it. So we could do 15 times 2, and that's 30. So x is 30, BC is 30. In number 3, if DE is the midsegment, that means that E is the midpoint, and if E is the midpoint, then AE and CE are both 9. In question number 4, it says the vertices of a triangle are -5, 6, 3, 8, and 1, -4. Let's plot these in GeoGebra. Here are the coordinates. Let's make the triangle. And if we make the midpoints, the midpoint of AB is -1, 7. The midpoint of BC is E, which is 2, 2. And the midpoint of AC is F, or -2, 1. So this is the mid-segment triangle we didn't actually draw yet. We just got to connect the midpoints together, and that's the mid-segment triangle. And they are -1, 7, 2, 2, and -2, 1. In question 5, it says, what is the perimeter of triangle DEF, which is the mid-segment triangle? So if we know that A to B is 13, then half of that would be 6.5, which would be this one. If we know that A to C is 38, then half of 38 would be 19, which would be this one right here. And half of 45 would be 22.5. It would be this one right here. So now to find the perimeter of the mid-segment triangle, we need to do 19 plus 22.5 plus 6.5. Which is 48. Another way to do this problem would be to add up the 3 sides of the original triangle. So 13 plus 38 plus 45, which is 96. And then to take that and divide that by 2. Either way, we get 48 units for the perimeter of DEF. In the diagram, DE is the midsegment of triangle ABC, and FG is the midsegment of triangle ADE. Find FG. So to find this one right here, we divide it by 2. Half of 52 is 26. Then we do half of 26 to find FG, and half of 26 is 13. So we could say that FG is 13 units. In this example 1, there's a lot of information on this slide. It says it's a very short question. In triangle JKL, show that the midsegment MN is parallel to JL, so that this red segment's parallel to this blue segment JL, and show that MN is half of JL. So there's 3 steps. Here's what the book has, and here's my summary here. First, we need to find the midpoints to get M and N. So that should be straightforward enough. The midpoint of -6, 1 and -2, 5 is -4, 3. And the midpoint of -2, 5 and 2, -1 is 0, 2. The second step is to calculate the slopes using the slope formula to confirm that they are the same. We know that parallel lines have the same slope. So if we use the slope formula to find the slope of MN, that would be 2 minus 3 over 0 minus -4, which is -1/4. And the slope of JL, if we do -1 minus 1 over 2 minus -6, we get -2/8, which is -1/4. So since we showed that the slopes are the same, we know that these 2 lines are parallel. Third and finally, they want us to find that MN is half of JL, or that JL is double MN. And to do that, we're going to calculate the lengths by using the distance formula to confirm that they're half or double, depending on which way you want to show it. So MN is equal to the square root of, now this is where we're applying the distance formula, x minus x squared plus y minus y squared. In this specific case, we get 16 plus 1, or the square root of 17. That's MN. Now JL, when we apply the distance formula, gives us the square root of 68. Now, we're going to have to simplify that radical to become 2 square root of 17. And we'll talk more about that. You've covered that in your Algebra 1 class, but we'll give it a review. We see that since those are 2 root 17 is 2 times root 17, we know that we have confirmed that it's JL is double the length of MN, and MN is half the length of JL. As we work on problems in our book, it's going to have us working with showing in this mid-segment triangle that DE is parallel to CB and half its length, that EF is parallel to AC and half its length, and that DF is parallel to AB and is half its length. So we're going to take that 3-step process for that as well. Then you'll have questions like this, which in my opinion are a little bit simpler, more straightforward, where we basically need to half or double things. In numbers 13 through 16, you're going to complete each statement to say what's parallel to what and what's congruent to what. And that's section 6.4, mid-segment triangles.